All right, so we want to evaluate each expression using the graphs as shown. Okay, so this is a composite function. So for part A, I want to find g of f of 3. That's how you would interpret that. So f of 3 would be when I go to x equals 3 on my f graph, that's -1. So f of 3 is -1, so this reduces to g of -1 because f of 3 is -1. So then g of -1, when I go to -1 on the g graph, that's 5. So this is equal to 5. All right, for b, f of g of 3 is f of g of 3. We first find g of 3. Well, here's x equals 3. G of 3 is going to be 3. So that reduces to f of 3. So g of 3 just becomes 3, and now I want f of 3. Well, f of 3, if I go over to 3, f when x equals 3 is -1. So there's -1. All right, let's do that for all of these. So g of f of 0 is g of f of 0. So look at graph f and look at when x is 0. That would be 2. So you're basically, this is the x value, and you're finding the y value. And whether it's f or g tells you which graph to look at. So this is the f graph when x is 0, y is 2. So g of 2. Now I want x to be 2. I'm looking at the g graph. So x is 2. The g graph tells me that is 4. All right, and last but not least, f of g of 4 is f of g at 4. So g at 4, here's 4. There's g. The answer is 4. So now I want f of 4. All right, well, here's 4. Here's f. It's equal to 0. And there's your answer. And that's how composite functions work.